Hello everyone. In this lecture video, we'll be continuing with Module 4 of Computer Communication Network, that is Network Layer Protocols. In the previous lecture video, we'd stopped at fragmentation. In this lecture video, we'll be starting with options. The header of the IPv4 datagram is made up of two parts, a fixed part and a variable part. The fixed part is 20 bytes long and was discussed in the previous section. The variable part comprises the options that can be a maximum of 40 bytes in multiples of 4 to preserve the boundary of the header. Options, as the name implies, are not required for a datagram. They can be used for network testing and debugging. Although options are not a required part of IPv4 header, option processing is required of the IPv4 software. This means that all implementations must be able to handle options if they are present in the header. Options are divided into two broad categories, single byte options and multi-byte options. We give a brief description of the options here. For a complete description, we can study further about, especially about the options from different sources on the internet. So what do you mean by single byte option? There are two single byte options, no operation and end of operation. No operation. A no operation is a one byte operation used as filter between options. And end of option is also a one byte option used for padding at the end of the option field. It, however, can only be used as the last option. Next is multiple byte option. There are four multiple byte options. They are record route, strict source route, loose source route, and timestamp. What do you mean by record route? A record route option is used to record the internet routers that handle the datagram. It can list up to 9 router addresses. It can be used for debugging and management purposes. Next one is the strict source route. A strict source route option is used by the source to predetermine a route for the datagram as it travels through the internet. Dictation of a route by the source can be useful for several purposes. The sender can choose a route with a specific type of service such as minimum delay or maximum throughput. Alternatively, it may choose a route that is safer or more reliable for the sender purpose. This is about a strict source route. Next is a loose source route. A loose source route option is similar to the strict source route, but it is less rigid. Each router in the list must be visited, but the datagram can visit other routers as well. This is about the loose source route. The last one of the multi-byte is timestamp. A timestamp option is used to record the time of datagram processing by a router. The time is expressed in milliseconds from midnight, universal time, or Greenwich Mean Time. Knowing the time a datagram is processed can help users and managers track the behavior of the router in the internet. We can estimate the time it takes for a datagram to go from one router to another. We say estimate because although all routers may be a universal time, their local clocks may not be synchronized. I repeat once again, we can estimate the time it takes from a datagram to go from one router to another. We say estimate because although all routers may use universal time, their local clocks may not be synchronized. This is about the options. Next is the security of IPv4 datagram. The IPv4 protocol, as well as the whole internet, was started when the internet users trusted each other. No security was provided for the IPv4 protocol. Today, however, the situation is different. The internet is not secure anymore. Here, we give a brief idea about the security issues in IP protocol and the solutions. There are three security issues that are particularly applicable to the IP protocol. First one is packet sniffing, packet modification, and IP spoofing. So what do you mean by packet sniffing? An intruder may interrupt an IP packet and make a copy of it. Packet sniffing is a passive attack in which the attacker does not change the content of the packet. This type of attack is very difficult to detect because the sender and the receiver may never know that the packet has been copied. Although packet sniffing cannot be stopped, encryption of the packet can make the attacker's effort useless. The second one is the packet modification. The second type of attack is to modify the packet. The attacker intercepts the packet, changes its contents, and sends the new packet to the receiver. The receiver believes that the packet is coming from the original sender. This type of attack can be detected using a data integrity mechanism. The receiver, before opening and using the contents of the message, can use this mechanism to make sure that the packet has not been changed during the transmission. Third one is the IP spoofing. An attacker can masquerade as somebody else and create an IP packet that carries the source address of another computer. An attacker can send an IP packet to a bank pretending that it is coming from one of the customers. This type of attack can be prevented using an origin authentication mechanism. These are the three types of security issues in IP4 V4 datagram. Next, we'll be studying about IPsec, that is IP Security Protocol. The IP packets today can be protected from the previously mentioned attacks using a protocol called IPsec. This protocol, which is used in conjunction with the IP protocol, creates a connection-oriented service between two entities in which they can exchange IP packets without worrying about the three attacks discussed above. IPsec provides the following four services: defining algorithms and keys, packet encryption, data integrity, and origin authentication. So, what do you mean by defining algorithms and keys? The two entities that want to create a secure channel between themselves can agree on some valuable algorithms and key to be used for security purposes. Packet encryption is that the packet exchange between two parties can be encrypted for privacy using one of the encryption algorithms and a shared key agreed upon in the first step. This makes the packet sniffing attack useless. Data integrity guarantees that the packet is not modified during the transmission. If the received packet does not pass the data integrity test, it is discarded. This prevents the second attack, packet modification. Origin authentication is the fourth one. IPsec can authenticate the origin of the packet to be sure that the packet is not created by an imposter. This can prevent IP spoofing attacks as we have discussed above. This is about security of IPv4 datagram. Next is ICMPv4. The IPv4 has no error reporting or error correcting mechanisms. What happens if something goes wrong? What happens if a router must discard a datagram because it cannot find a route to the final destination, or because the time to leave field has a zero value? What happens if the final destination host must discard the received fragments of a datagram because it has not received all fragments within a predetermined time limit? There are examples of the situation where an error has occurred and the IP protocol has no built-in mechanism to notify the original host. The IP protocol also lacks a mechanism for host and management queries. A host sometimes needs to determine if a router or another host is alive, and sometimes a network manager needs information from another host or router. The ICMP4, that is Internet Control Message Protocol version 4, has been designed to compensate for the above two deficiencies. It is a companion to the IP protocol. ICMP itself is a network layer protocol. However, its messages are not passed directly to the data link layer as would be expected. Instead, the messages are first encapsulated inside the IP datagram before going to the lower layer. When an IP datagram encapsulates an ICMP message, the value of the protocol field in the IP datagram is set to 1 to indicate that IP payload is an ICMP message. This is about ICMP v4. Next is messages. ICMP messages are divided into two broad categories. One is error reporting messages and query messages. Error reporting messages report problems that a router or a host, that is the destination, may encounter when it processes an IP packet. The query message, which occurs in pairs, help a host or a network manager get specific information from a router or another host. For example, nodes can discover their neighbors. Also, hosts can discover and learn about routers on their network, and routers can help a node redirect its messages. An ICMP message has an 8-bit header and a variable size data section. Although the general format of the header is different for each message type, the first 4 bytes are common. So the figure shows the first field ICMP type defines the type of the message. The code field specifies the reason for a particular message type. The last common field is the checksum field. The rest of the header is specific for each message type. The data section in error messages carries information for finding the original packet that had the error. In query messages, the data section carries extra information based on the type of the query. Next are the error reporting messages. Since IP is an unreliable protocol, one of the main responsibility of the ICMP is to report some errors that may occur during the processing of the IP datagram. The ICMP does not correct errors. It simply reports them. Error correction is left to the higher level protocols. Error messages are always sent to the original source because the only information available in the datagram about the route is the source and the destination IP address. These are the important points about ICMP error message. The first one is no ICMP error message will be generated in response to a datagram carrying an ICMP error message. The second one is no ICMP error message will be generated for a fragmented datagram that is not the first fragment. Third one is no ICMP error message will be generated for a datagram having a multicast address. And the last one, that is the fourth one, is no ICMP error messages will be generated for a datagram having a special address such as 127.0.0 or 0.0.0. Note that all error messages contain a data section that includes the IP header of the original datagram plus the first 8 bytes of the data in that datagram. The original datagram header is added to give the original source which receives the error message information about the datagram itself. The 8 bytes of the data are included because the first 8 bytes provide information about the port numbers, that is UDP and TCP, and sequence number TCP. This information is needed so that the source can inform the protocols, that is TCP or UDP, about the error. ICMP forms an error packet which is then encapsulated in an IP datagram as shown in the figure. That is the contents of the data field. We have studied about this just now. Next is the types of error messages. The first one is destination unreachable. The most widely used error message is the destination unreachable, that is a type 3. This message uses different codes 0 to 15 to define the type of error message and the reason why a datagram has not reached its final destination. The second one is source quench. Another error message is called as source quench. It is type 4 message, which informs the sender that the network has encountered congestion and the datagram has been dropped. The source needs to slow down sending more datagrams. In other words, ICMP adds a kind of congestion control mechanism to the IP protocol by using this type of message. The third type is redirection message. The redirection message, that is type 5, is used when the source uses a wrong router to send out its message. The router redirects the message to the appropriate router but informs the source that it needs to change its default router in the future. The IP address of the default router is sent in the message. This is redirection message. Next one is the parameter problem. A parameter problem is the type 12 can be sent when either there is a problem in the header of a datagram, that is code 0, or some options are missing or cannot be interpreted. That is code 1. This is a parameter problem. Next is the query messages. Interestingly, query message in ICMP can be used independently without a relation to an IP datagram. Of course, a query message needs to be encapsulated in a datagram as a carrier. Query messages are used to probe or test the liveliness of hosts or routers in the internet. Find the one way or the route trip time for an IP datagram between two devices, or even find out whether the clock in two devices are synchronized. Naturally, query messages come in pairs, that is, the request and reply. The echo request, that is type H, and the echo reply type 0 pair of messages is used by the host or the router to test the liveliness of another host or router. A host or router sends an echo request message to another host or router, a router. If the latter is alive, it responds with an echo reply message. We shortly see the application of this pair in the two debugging tools in the future videos. Thank you.